All right, so now we're going to talk about 12-factor apps. This is kind of an initiative that's starting to permeate its way through the industry. At its core, it's really all about designing your services to be simple and lightweight and reproducible, so that when problems occur, there's an easy way to get back and reproduce the problem and find out what's going on. So we're just very briefly going to zip through the 12 factors of the 12-factor app initiative, if you will. And kind of zip through them. Again, remember, they're all focused on simplicity and speed and reproducibility. So the first is you should have a single repro for all of your code, and don't share code with another app. This keeps things independent. It doesn't set up dependencies between different repros or different teams in your organization, and it allows you, again, to be agile and move quickly by reducing those kinds of dependencies. Number two is deploy dependent libs with your app. Your app should be completely self-contained. It shouldn't have some dependencies that are required at runtime. And the reason for that is because when you test, if you have a dependency there when you test, and this is very common scenario, then if the dependency is on your local machine, everything works correctly. Then a lot of times people take their application, they deploy it to another machine, they didn't deploy the dependency with the app, and now the application doesn't work correctly. And then it can take a while to track that down. What's wrong? Oh, I don't have the right dependency. Or maybe I have the dependency there, but it's the wrong version. So by always packaging the proper versions of the dependencies with your application in a consistent environment, then it should have more consistent behavior when you run it in different locations, locally, testing, staging, production, and so on. Number three is do not put configuration in code. Instead, read the configuration from environment variables. So the reason for this is code gets checked into a repository. Sometimes people put into configuration things like passwords, certificate information, some kind of connection strings, and to other services that you need. These things can move around. Endpoints can move around. Certainly, certificates, they roll over when they expire. Passwords, they change periodically. This is not the kind of information that you should be embedding in your code, and it is certainly not the kind of information that you should be checking into a source repo. So you should have an external way of managing this kind of information, but the application, of course, needs to get access to it when it is running. So the recommendation is to not embed this in your code, and instead put it into environment variables which your application can read at runtime. Number four. Handle unresponsive app dependencies robustly. I said this in the previous video, but it's worth repeating again. In this world where we have lots of services communicating with each other and service instances, we dynamically scale them up and we dynamically scale them down, so the instances come and go. Endpoints are changing all the time. And network communication can also be somewhat brittle. So you have to make sure that any code that you write that does communication is robust and reliable against these kinds of failures. That requires a lot of discipline on the programmer's part to handle this stuff correctly. And then test. You must test, of course. Number five, strictly separate the concept of build, release, and run steps. So for build, what we mean is this builds a version of your code repo, and it gathers all of the dependency libraries together too. So now we know this is the code that we're going to be deploying. Now, the release step is going to combine that build with all of the configuration information. So that's the environment variables that I was talking about before. And this gives you a release ID. The release ID could be a GUID, or it could be a date timestamp. It could be whatever you want it to be. But the most important thing here is that you consider it to be immutable. You should always have a way to get back to this was the version of the code and the version of the dependencies and this set of configuration. That would allow, if something is failing somewhere, you can recreate this, get it onto a developer's machine, and try to reverse engineer what went wrong so that you can easily find bugs and fix them in your code. And then the last step is run. Run is, of course, when you take all of that release and then you run it in some kind of execution environment. Again, it could be on the developer's machine, or it could be in production or staging, and so on. Now, the remaining steps of the 12-factor apps I show on this slide here. Step number 6 is consider your app to be one or more stateless processes, and they share nothing with each other. Again, we want to remove dependencies as much as possible. Step 7 is have the app listen on ports And avoid using hosts like web hosts, because these introduce, again, more uncertainty into what's happening there. When you have more control over the ports themselves, you're getting some other black boxes out of the equation, and it makes your service more predictable. It also removes overhead. A lot of these hosts, they do offer a lot of features that a lot of applications don't need, but you pay for it in the way of memory consumption and performance, and you want your services to be fast. The faster they are, the fewer machines you need, and that ends up saving you money and costs in running your service. Number 8, use processes for isolation and use multiple processes for concurrency. Again, this is removing dependencies, and it's isolating one process for another. If one process is handling a client request and it gets an exception for some reason, then that process goes down. But other processes running that are handling other client requests, they can continue to execute. So the other clients are having a good experience, even though one client request is having a problem. Step number 9. Processes can crash or be killed forcibly quickly, and they need to start fast. What this is really saying to you is you should realize that your process could go down at any time. First of all, hardware failure is inevitable, and a power supply could go down, something like that, and your app is just not running anymore. This tends to be a problem if your application is accumulating like diagnostic and monitoring data on the machine. Well, if the machine goes down, then you can't get that data off of the machine to send it to that holistic repository where you could aggregate everything together. So when you're thinking, if I'm accumulating diagnostic data on the machine, should I upload it to the external store once a minute, once every second? Well, you have to realize the longer time you have there, if the machine goes down, that machine may have accumulated, let's say, 10 minutes worth of data, if you push every 10 minutes. And then if the machine goes down, you may have lost 10 minutes worth of data. So you need to think about that. And then start fast. And if another reason why you might crash, by the way, or go down is the administrator is trying to scale your service down. So you might have 100 instances running, they scale you down to 50, 50 instances will just be killed. And maybe when we're scaling up, we're going from 50 back to 100, that means we're starting you up. And so you want to start fast. In other words, don't take a long time to initialize your service, right? When your main method gets called to get started running, you want to do as minimal initialization as possible so that you're ready to handle the client request as quickly as possible. Number 10, keep your development environment, staging, and production environments all similar to each other. Right? Don't have wild differences between them because, again, you're testing in one, like the example I gave earlier where the development environment had some dependencies, but those dependencies were not available in staging or production environment. So everything tested great on the developer's machine, but then doesn't work somewhere else. The more similar these environments are to each other, the more likely it is your testing and the runtime is going to be identical and work fine and cause you fewer problems when you're finally in production. Number 11, logging should be very simple and straightforward. Your applications should be console applications, and they should just be simply writing their logs to standard output. When a developer is testing their code on their local machine, then they will just see the output appear in the console window, and they can see all the trace events that are happening. When the application or service is running in production, then standard output can be redirected to a file, and then that file's contents can periodically be written to that external store where it can be aggregated with the other information from the other service instances to give you that holistic view. And finally, number 12 is to deploy and run administrative tasks, that is scripts, as processes. And this is really saying here, an administrator shouldn't be going into a box and setting configuration. Anything that you need to do should be reproducible. So any configuration should be scripted, and it should be executed on every machine in a very consistent way so that everything has the same behavior. And that is really it for the 12-factor apps. Again, it's all about simplicity and keeping things fast and allowing you to be agile as you are building your service and deploying it.